Now, in this lecture, we find out the radius of a circle. In the drawing, we have a right triangle, triangle ABC. Inside this right triangle, we have this circle. And our mission is to find out the radius of this circle. In addition, we know that line segment AS, this line segment AS equals to 1 unit in its length. This is line segment SC that is equals to 3 units in its length. And line segment TC equals to 2 times square root of 3 units in its length. This is angle ABC, that is the right angle. I repeat again that our mission is to find out the radius of this circle. So we define the center of this circle, this point, as O. And we define the radius of this circle, that is the radius that we are looking for, as X. So the radius of this circle equals to X according to our definition. In the next step, we will join points O and Q together by a straight line. So what is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and ends at point Q, that is the point of the circle itself. This is exactly the definition of a radius. Therefore, OQ is the radius of the circle. It equals to X according to our definition. You can implement here rule 1 and repeat quickly on rule 1. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle and we have tangent AB. This is tangent AB. This is tangent to this circle here at this point, point M. And we have the radius OM that is equal to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. You can implement rule 1 in our drawing. In our drawing, we have the radius OQ that is equal to X. The radius OQ is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by a straight line. Line segment OP. Line segment OP is the radius of this circle that is equal to X. According to our definition, you can implement rule 1. We have the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to rule 1. So inside the quadrilateral OPBQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule. Then the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this missing fourth angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrilateral POQB to 360 degrees, the missing fourth angle must be equal to 90 degrees in size. So actually found out that inside quadrilateral POQB we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to this quadrilateral POQB is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So in rectangle POQB, side PO must be equal to the opposite side BQ. But PO equals to X, therefore BQ must be also equal to X because of the fact that they are equal to each other. Likewise, according to the same rule, and in the same rectangle POQB, side OQ must be equal to the opposite side PB, but OQ equals to X, therefore PB must be also equal to X. So actually found out that this quadrilateral POQB is not a rectangle but a square, but because of the fact that all the sides of this quadrilateral POQB are equal to each other. Each side equals to X. In the next step, we define the length of this line segment AP as A. And we define the length of this line segment QC as B. We can implement here rule 10 and page quickly on rule 10. According to rule 10 is true in any circle. So according to rule 10, if we have a common external point P, and from the common external point P, we draw tangent PT. This is tangent PT, this is tangent to this circle here at point T. And we have also chord BA. The extended chord BA touches the common external point point P here. So if you extend chord BA until it touches P, the common external point P, we get this drawing. In this drawing, the following equation is true. That PT square equals to PA times PB. Again, PT square equals to PA times PB. We can implement rule 10 in our drawing. Why? Because in our drawing, if we focus on this common external point A, from the common external point A, we have tangent AP, that is tangent to this circle at point P, and we have chord TS. The extended chord TS touches the common external point A here. So all the requirements of rule 10 are satisfied, therefore we can implement here rule 10. According to rule 10, AP square equals to AS times AT. Again, AP square equals to AS times AT. So I write it down. In the common external point A, according to rule 10, AP square equals to AS times AT. Repeat again. If we focus on the common external point A, we can implement in our drawing rule 10. According to rule 10, AP square equals to AS times AT. Okay, so AP square. AP equals to A, therefore AP square is A square. And A square equals to AS. AS is 1 times 80. 80 equals to 1 plus 3. In conclusion, I should have found out that according to rule 10, A square equals to 1 times 1 plus 3. So A square equals to 1 times 1 plus 3, that is 4. And 1 times 4 is 4. In conclusion, found out actually that A square equals to 4. Here we take a root out of this equation. And finally, we'll get that a equals to the square root of 4, that is 2. So a equals to 2 units in its length. Note it down here, the drawing, that a equals to 2 units in its length. Likewise, we'll implement rule 10 on this current start point C. For the current start point C, we have tangent CQ, that is tangent to this circle here at point Q, and we have the extended chord ST touches the current start point C here. So all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, we get that CQ square equals to CT times CS. Repeat again. According to rule 10, we get that CQ square equals to CT times CS. CQ is B according to our definition. Here CQ equals to B. Therefore CQ square equals to B square. And B square equals to CT. CT equals to 2 times square root of 3 according to what is given as the question. Times CS. CS from the drawing is very easy to see. That CS in total equals to 3 plus 2 times square root of 3. Again, CS in total equals to 3 plus 2 times square root of 3. In conclusion, I have found out that B square equals to 2 times square root of 3 plus 3 times 2 times square root of 3. Here we'll open the brackets on this side of the equation, and we get that B square equals to 2 times 3 times square root of 3 plus 2 times square root of 3 times 2 times square root of 3 is 12. Why? Because of the fact that 2 times 2 is 4, and square root of 3 times square root of 3 is 3, and 4 times 3 is 12. So we found out that 2 times square root of 3 times 2 times 3 times square root of 3, that B square equals to 2 times 3 times square root of 3 plus 12. We will substitute 12 by 9 plus 3, and we get that B square equals to 12, that is 9 plus 3, plus 2 times 3 times square root of 3. So actually, this expression, 9 plus 3 plus 2 times 3 times square root of 3, is very similar to the algebraic identity that states that a square plus b square plus 2 times a times b equals to a plus b square. If we just substitute a by 3 and we substitute b by square root of 3, we get that a is 3, therefore a square is 3 squared, that is 9. We have here 9 plus b square. B is square root of 3, therefore b square is square root of 3 squared, that is 3. So we have 9 plus 3 plus 2 times ab. 2 times a is 3, so it is 2 times 3 times b, that is square root of 3. Okay, so we actually found out that if we substitute a by 3 and b by square root of 3 in this algebraic identity, we get actually this expression 9 plus 3 plus 2 times 3 times square root of 3 is equals to a square plus b square plus 2 times ab. And because of the fact that a square plus b square plus 2 times ab equals to a plus b square, it means that this expression will be equal to a plus b square. When a equals to 3, therefore, so it is equals to a, that is 3, plus b, that is square root of 3 square. In conclusion, we found out that 9 plus 3 plus 2 times 3 times square root of 3 equals to a plus square root to 3 plus square root of 3 square. According to this algebraic identity, that a squared plus b squared plus 2 times ab equals to a plus b squared. And this expression equals to b squared. Therefore, b squared equals to 3 plus square root of 3 squared. So here we take a root out of this expression and we get that b equals to 3 plus square root of 3. So b equals to 3 plus square root of 3. Square root of 3 is 1.732, therefore b equals to 3 plus 1.732. 3 plus 1.732 equals to 4.732. In conclusion, we actually found out that b equals to 4.732 units. Second line down here, that b equals to 4.732 units in its length. That is to say, 97 QC is equal to b, it is equal to 4.732 units. And we already found out that line 70 AP equals to a and a equals to 2. So in the next step, we will implement the Pythagoras theorem on this right Greek triangle, triangle ABC. Repeat again. We will implement the Pythagoras theorem on this right triangle, triangle ABC. Here by PT is the evaluation from Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse on this right Greek triangle, triangle ABC is AC, therefore the square of the hypotenuse is AC square, and it must be equal to AB square plus BC square. Repeat again, according to the Pythagoras theorem in the right triangle ABC, AC square equals to AB square plus BC square. Okay, so AC, from the drawing it is very easy to see that AC in total equals to 1 plus 3 plus 2 times root of 3. So AC equals to 1 plus 3, that is 4, plus 2 times root of 3. In total, AC equals to 4 plus 2 times root of 3. So AC equals to 4 plus 2 times root of 3. Therefore, AC square will be equal to 4 plus 2 times root of 3 square. Repeat again, AC square will be equal to 4 plus 2 times root of 3 square, and it must be equal to AB square. From the drawing, it is very easy to see that AB equals to x plus 2. Therefore, AB square equals to x plus 2 square plus BC square. From the drawing, it is very easy to see that BC equals to x plus 4.732. Therefore, BC square will be equal to x plus 4.732 square. In conclusion, we found out that 4 plus 2 times root of 3 square equals to x plus 2 square plus x plus 4.732 square. And 4 plus 2 times root of 3 square equals to 55 4.7128. Repeat again. 4 plus 2 times root of 3 square. In total it is equal to 55.7128. And it must be equal to x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 square, that equals to x square, plus 4.732 square is equals to 22.3918 plus 2 times x times 4.732, that is actually equals to 9.464x. So in conclusion, we actually found out that 55.7128 equals to, here we have x squared plus x squared is 2x squared. In this side of the equation we have 4 plus 22.3918, that is 26.3918 plus 4x plus 9.464x equals to 13.464x. In conclusion, we actually found out that 55.7128 equals to 2x squared plus 26.3918 plus 13.464x. Here we subtract 55.7128 from this equation. And we get that in this side of the equation we left with nothing, 0. And it is equals to, on the other side of the equation we have 2x squared and 26.3918 minus 55.3128 equals to minus 29.321 plus 13.464x. So here we divide this equation, this quadratic equation by 2, and finally we'll get that 2x squared over 2 is x squared minus 29.321 over 2 is minus 14.66, and 13.464 over 2 is equal to 6.32x. So in conclusion, we actually found out that x squared plus 6.32x minus 14.66 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. We will find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, this is actually x squared plus 6.732x minus 14.66 equals to 0. The coefficient a equals to 1. The coefficient b equals to 6.732, and finally the coefficient c equals to minus 14.66. So we just have to put the data for our specific quadratic equation, the values of a, b, and c, in this general formula for x, in order to find out the value of x in our specific quadratic equation. Okay? So x, the general formula is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Repeat again. We will put the data for our specific quadratic equation for a, b, and c in this general formula for x in order to find out the value or the values of x for our specific quadratic equation. I will remind you that x in our quadratic equation, x is the radius of this circle. Okay, so we do it now, and we get that x equals to minus b. b in our specific quadratic equation is equals to 6.732, therefore minus b is minus 6.732 plus minus square root of b squared. b is 6.732, therefore b squared 6.732 squared that is actually equals to 45.3198 minus 4 times a is 1, so minus 4 times 1 is minus 4, times c, that is minus 14.66. So minus 4ac in total is minus 4 times minus 14.66, that is actually equals to 58.64 divided by 2a. a is 1, so 2a is 2 times 1, that is 2. In conclusion, we found out that x equals to minus 6.732 plus minus square root of 45.3198 plus 58.64 all under the root divided by 2. So x equals to minus 6.732 plus minus, inside the root we have 45.3198 plus 58.64. This is actually equals to 103.9598 divided by 2. So x equals to minus 6.732 plus minus the square root of 103.9598 is equal to 10.196 divided by 2. So here we will have two solutions that are possible for x. The first solution for x is that x equals to minus 6.732 minus 10.196. That is definitely a negative number, and because of the fact that x is the radius of this circle, x is a radius, x is a length, and as a length it must be a positive number, so the negative solution is incorrect. We cancel the negative solution, and we're left only with the positive solution that is possible for x. The positive solution for x is that x equals to minus 6.732 plus 10.196 divided by 2. So x equals to 10.196 minus 6.732. That is actually equals to 3.46 divided by 2. So x equals to 3.46 over 2. That is actually 1.732. In conclusion, we actually found out that x equals to 1.732 units in its length. Repeat again. The radius x of this circle is equals to 1.732 units in its length. So we finish with the question. In the next step, I summarize the lecture. So in this lecture we found out the radius of this circle. So in the drawing we have the right triangle ABC. Inside this right triangle ABC we have this circle. Our mission to find out the radius of this circle. In addition, we know that this is line segment AS that is equal to 1 unit in itself. This is line segment SC that is equal to 3 units in itself. And this is line segment TC that is equal to 2 times square root of 3 units in its length. This is angle ABC, that is a right angle. Again, our mission is to find out the radius of this circle. So, in the first step, we define the center of this circle, this point as O, and we define the radius of this circle, that is the radius that we are looking for in this question. We define the radius of this circle as x. In the next step, we join points O and Q together by straight lines. What is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of this circle, and ends at point Q, that is the point on the circle itself. This is exactly the definition of a radius. Therefore, OQ is the radius of this circle that is equal to x according to our definition. We can implement here all 1. Why? Because we have the radius OQ that is 1 to point Q, that is the point of tendency of tangent BC with this circle. Whenever we have a radius that is 1 to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by straight line. OP is the radius of this angle that is equal to x. We have the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this angle. Whenever your radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. So inside quadrilateral OPBQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 300 to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing fourth angle here must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside quadrilateral PBQO to 360 degrees, the missing fourth angle, this missing fourth angle must be equal to 90 degrees in its size. So inside quadrilateral OPBQ we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrilateral POBQ as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So in rectangle POBQ, side PO must be equal to the opposite side BQ. But PO equals to x, therefore BQ must be also equal to x because of the fact that they are equal to each other. Likewise, according to the sum rule, in the sum rectangle POQB, side OQ must be equal to the opposite side PB, but OQ equals to x, therefore PB must be also equal to x because of the fact that they are equal to each other. So I actually found out that quadrilateral POQB is not a rectangle but a square. Right, because all of the sides of quadrilateral POQB are equal to each other. Each side equals to x. So we define this line segment AP as A and we define this line segment QC as B. Here we implemented rule 10. I'll take quickly on rule 10. According to rule 10, if you have a circle, then you have the common standpoint point P. From the common standpoint point P, we draw tangent PT that is tangent to this circle point T, and we have also chord BA that is extended until the common standpoint point P. So in this moment, the following equation is true, the following formula is true, that PT squared equals to PA times PB. Again, PT squared equals to PA times PB. We can implement rule 10 in our drawing. Well, because in our drawing, if you focus on the common standpoint point A, from the common standpoint point A, we have tangent AP, that is tangent to this equal point P, and we have chord TS, and the extended chord TS touches the common standpoint point A. Therefore, all the requirements of rule 10 are satisfied, and therefore we can implement rule 10. According to rule 10, AP squared equals to AS times AT. Again, AP squared equals to AS times AT. Repeat again, if you focus on the common standpoint point A, according to rule 10, AP squared equals to AS times AT. AP is A, therefore AP squared is A squared, AS is 1, and AT is 1 plus 3. So in conclusion, actually found out that according to rule 10, A squared equals to 1 times 1 plus 3. So A squared equals to 1 times 1 plus 3, that is 4. So A squared equals to 1 times 4, that is 4. A squared equals to 4. Here we took out of this equation and finally found out that A equals to the square root of 4, that is 2. Likewise, we implemented rule 10 on this common standpoint point C. We can implement rule 10 in the common standpoint point C. Why? Because of the fact that from the common standpoint point C, we have tangent CQ. This is tangent CQ that is tangent to this equal point Q, and we have chord, the extended chord ST touches the common standpoint point C. Therefore, all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, CQ square equals to CT times CS. Again, CQ square equals to CT times CS. Repeat again. If you focus on the current standpoint point C, according to rule 10, CQ square equals to CT times CS. CQ is B, therefore CQ square is B square, and it is equals to CT. CT is 2 times square root of 3, and CS is 3 times 2 times square root of 3. So in conclusion, we actually found out that B square equals to 2 times square root of 3 times 3 plus 2 times square root of 3. Here we open the brackets on this side of the equation, and finally found out actually that B square equals to 2 times 3 times square root of 3, and here we have 2 times square root of 3 times 2 times square root of 3 is 12. 5 plus 2 times 2 is 4, and square root of 3 times square root of 3 is 3, and 4 times 3 is 12. So in conclusion, actually found out that B square equals to 2 times 3 times square root of 3 plus 12. We substitute 12 by 9 plus 3, and finally found out that B square equals to 12, that is 9 plus 3 plus 2 times 3 times square root of 3. This expression 9 plus 3 plus 2 times 3 times square root of 3 is very similar to the algebraic identity a squared plus b squared plus 2 times ab. And according to this algebraic identity, a squared plus b squared plus 2 times ab equals to a plus b squared. Why those two expressions are similar to each other? Because of the fact that if we define a in this algebraic identity as 3 and b is equal to 3, we get that a squared plus b squared plus 2 times ab equals to 9 plus 3 plus 2 times 3 times square root of 3. Why? Because if a is 3, then a squared is 9. Here we have b is equal to 3, therefore b squared is 3, so it is 9 plus 3. And finally, plus 2 times ab. So it is plus 2 times a is 3, 2 times 3 times b, that is equal to 3. So if we actually found out that 9 plus 3 plus 2 times 3 times square root of 3 is actually identical to a squared plus b squared plus 2 times ab if we define a as 3 and b is equal to 3. And this expression equals to a plus b squared, and therefore 9 plus 3 plus 2 times 3 times square root of 3 will be equal to a plus b squared. In our specific expression, a plus b squared equals to a is 3 and b is equal to 3. So a plus b squared will be equal in total to 3 plus square root of 3 squared. And according to this equation, it is equal to b squared. Therefore, b squared will be equal to 3 plus square root of 3 squared. Here we took out of this equation and finally found out that b equals to 3 plus square root of 3. 3 plus square root of 3, square root of 3 is 1.732, therefore b equals to 3 plus 1.732, and 3 plus 1.732 equals to 4.732. So we found out actually that b, the value for line segment Q3 that is b, it is equal to 4.732 units, and we found out that line segment AP is equal to a, according to our definition, it is equal to 2. So in the next step, we implemented the Pythagoras theorem on this big right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In this right triangle ABC, the hypotenuse is AC, therefore the square of the hypotenuse is AC square, and AC square must be equal to AB square plus BC square. Repeat again, in the right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. AC in total, it is very easy to see that AC in total equals to 4 plus 2 times square root of 3, therefore AC square is 4 plus 2 times square root of 3 square, and it must be equal to AB square. AB is x plus 2, therefore AB square is x plus 2 square, plus BC square. BC is x plus 4.732, therefore BC square is x plus 4.732 squared. So in conclusion, we actually found out that 4 plus 2 times square root of 3 squared equals to x plus 2 squared plus x plus 4.732 squared. 4 plus 2 times square root of 3 squared equals to 55.7128, and x plus 2 squared equals to x squared plus 2 squared, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 squared is equals to x squared plus 4.732 squared, that is equals to 22.3918, plus 2 times x times 4.732, that is 9.464x. So in conclusion, I actually found out that 55.7128 equals to, here we have x squared plus x squared is 2x squared, and we have also 4 plus 22.3918, that is 26.3918, and finally we have here 4x plus 9.464x equals to 13.464x. So in conclusion, I actually found out that 55.7128 equals to 2x squared plus 26.3918 plus 13.464x. Here we subtracted 55.7128 from this equation, and finally found out that in this side of the equation we left with nothing, that is to say 0. In the other side of the equation we have 2x squared. We have here, after we subtracted from this equation 59.7128, we get the 26.3918 minus 55.7128 equals to minus 29.321, and we have to add here also plus 13.464x. So in conclusion, I found out that 0 equals to 2x squared minus 29.321 plus 13.464x. Here we divided the equation by 2 and found out actually 2x squared over 2 is x squared, minus 29.321 over 2 is minus 14.66, and finally 14.464x over 2 is equals to 6.732x. So in conclusion, I found out that x squared plus 6.732x minus 14.66 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x, this general formula according to the following equation, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say x squared plus 6.732x minus 14.66 equals to 0, the coefficient a equals to 1, the coefficient b equals to 6.732, and the coefficient c equals to minus 14.66. I'll repeat again. In our specific quadratic equation, a equals to 1, b equals to 6.732, and c equals to minus 14.66. So we put the data for our specific quadratic equation inside this general formula for x, and we find out the value of x in our specific quadratic equation. That is what we did here. So we put the data from our specific quadratic equation, the values of, that is to say, the values of a, b, and c for our specific quadratic equation in order to find the value of x in our quadratic equation. We did it and we found out that x equals to minus b. b is 6.732, therefore minus b is minus 6.732 plus minus square root of b squared. B is 6.732, therefore b squared is 6.732 squared, that is 45.3198 minus 4 times AC. So it is minus 4 times A is 1, so minus 4 times 1 is minus 4, times C. C is minus 14.66, and minus 4 times minus 14.66 is 58.64. Divided by 2A. A is 1, so 2A is 2 times 1, that is 2. So in conclusion, actually found out that x equals to minus 6.732 plus minus square root of 45.3198 plus 58.64 divided by 2. So x equals to 6.732 plus minus, inside the root we have 45.3198 plus 58.64, that is equals to 103.9598. So inside the root we left only 103.9598, so x equals to minus 6.732 plus minus the square root of 103.9598 over 2. So x equals to minus 6.732 plus minus and the square root of 103.9598 is equals to 10.196 divided by 2. So x equals to, here we will have two solutions that are possible for x, because of the fact that x is the radius and the length of the radius. So x is a length, and as a length it must be a positive number. So we cancel the negative solution. X cannot be equal to minus 6.732 minus 10.196, that is a negative number. And we left only with the positive solution for x, that is to say x will be equal to minus 6.732 plus 10.16 divided by 2. And minus 6.732 plus 10.196 equals to 3.46, and 3.46 over 2 is 1.732. In conclusion, we found out that the radius of this circle x, it is equals to 1.732 units. Okay, thank you very much.